This one's the next video. It's called Higgs Boson Particle Yang-Mills Theory, Electroweak, Higgs Field, Global Symmetry, 5G Well SETI. All the videos are linked together on the Idea Girl Says YouTube channel. Now this is a graph of the Yang-Mills theory. Okay, so this prompted a significant restart of Yang-Mills theory studies that proved successful in the formulation of both electroweak unification and quantum chromodynamics, QCD. The electroweak interaction is described by SU2 times U1 group, while QCD is the SU3 Yang-Mills theory. The electroweak theory is obtained by combining SU2 with U1, where quantum electrodynamics, QED, is described by a U1 group, and is replaced in the unifield electroweak theory by a U1 group, representing a weak hypercharge rather than electric charge. The massless bosons from the SU2 and U1 theory mix after spontaneous symmetry breaking to produce the three massive weak bosons and the photon field. The standard model combines the strong interaction with the unified electroweak interaction, unifying the weak and electromagnetic interaction through the symmetry group SU2, U1, and SU3. In the current epoch, the strong interaction is not unified with the electroweak interaction, but from the observed running of the coupling constants, it is believed they all converge to a single value of very high energies. Phenomenology at lower energies in quantum chromodynamics is not completely understood due to the difficulties of managing such a theory with a strong coupling. This is the reason confinement has not been theoretically proven. Again, this is a continuation of the previous video where we talked about confinement, and it'll lead up to a formula sooner or later. Though it is a consistent experimental observation. Proof that QCD combines at low energy is a mathematical problem of great relevance, and an award has been proposed by the Clay Mathematics Institute for whoever is able to show that the Yang-Mills theory has a mass gap in its existence. My thoughts continue. Is the Yang-Mills theory describing what happens to the Higgs boson particle test results from CERN June 2012? Quote from the Yang-Mills theory: the massless bosons from the SU2 and U1 theory mix after spontaneous symmetry breaking to produce the three massive weak bosons and the photon field. So Google SU2 and U1, my thoughts, yes it does. The standard model, quote from Wiki, the standard model of particle physics, a renormalizable relativistic quantum gauge field theory based on the unitary product group SU3 x SU2 x U1, which is commonly viewed as containing the fundamental set of particles: leptons, quarks, gluons, bosons, and the Higgs particle. Higgs particle. It would prove the existence of the hypothetical Higgs field, the simplest of several proposed mechanisms for the breaking of electroweak symmetry, and the means by which elementary particles acquire mass. The leading explanation is that a field exists that has a non-zero strength everywhere, even in otherwise empty space, and that particles acquire mass by interacting with the so-called Higgs field. If this theory is true, a matching particle, the smallest possible excitation of the Higgs field, should also exist and be detectable, proving a crucial test of the theory. Consequently, it has been the target of a long search in particle physics, one of the preliminary goals of the Large Hadron Collider, LHC, at CERN in Geneva, Switzerland, the most powerful particle accelerator and one of the most complicated scientific instruments ever built, is to test the existence of the Higgs boson and measure its properties, which would allow physicists to validate this cornerstone of modern theory. My thoughts are continued. The hypothetical Higgs field is no longer hypothetical. CERN's test results from the 18th June 2012 prove that the Higgs boson particle field exists. With the new formulas from the WOW data cross-referenced with CERN Atlas and other test results pieced together, we should be able to figure this out soon. In 2012, we were promised to have new breakthroughs according to the Mayan Calendar, December 21st, 2012, prophecies of changes from the old world to a new one, meaning a new technological age. So I'm going to Google global symmetry, and a quote from Wiki: a global symmetry is a symmetry that holds at all points in the space-time under consideration, as opposed to a local symmetry which varies from point to point. Global symmetries require conservation laws but not forces in physics. So I Google electroweak theory, quotes from Wiki, in particle physics. The electroweak interaction is a unified description of the two of the four known fundamental interactions of nature, electromagnetism and the weak interaction. Although these two forces appear very different at everyday low energies, the theory models them as two different aspects of the same force. Above the unification energy on the order of 100 GeV, they would merge into a single electroweak force. Thus, if the universe is hot enough, approximately 10-15 K, a temperature exceeded until shortly after the Big Bang, then the electromagnetic force and weak force will merge into a combined electroweak force. Okay, so that's the end of that research video. I'm going to go on to the next one now.